Welcome back to the lab. In this video, we're going to be talking about how I vibe coded a C# library with Claude Code and 6 things that I learned along the way. So I spent a few hours vibe coding a new C# library with Claude Code last week, and here's a few things that I learned. First off, what did I vibe code? So I built Cinderblock HTML, a C# DSL for building HTML with composable building blocks. You can read the announcement post for more on why I built it, and this blog post linked here. Now I built it in a few hours over the course of 3 days. Now, I just had a baby, so my free time has been fleeting and sporadic because newborns wake up like every 2 to 3 hours to eat, something that I didn't really expect or prepare for. And so I want to note that without interruptions, this could have easily been done in a single sitting. But for me, and given my time constraints, I couldn't have a single sitting that long, so it took me 3 days. And for this project, I used Claude Code on the Pro plan, and I really only ran into rate limits once, though if I had more uninterrupted time, I probably would have hit these rate limits faster. The way that the rate limits work is you have like I think it's a 5-hour window to use some amount of things. And so, my sessions were split up across 3 days. I'd get like 30 minutes here, 1 hour here, 1 hour here. And so I only hit the rate limits once. But if I was doing an uninterrupted session where I had the 3 to 4 hours to work on it all at once, I probably would have hit them. And that would have blocked forward progress for me. So something to keep in mind. All right, so the first thing I learned is that, the CLI, or the command line interface, didn't bother me as much as I thought it would. I'm used to using Cline and VS Code, which offers a lot of GUI integrations, and, Copilot also has GUI integrations, and Cursor as well, although I haven't done Cursor as much as these others. And so I thought, the CLI seems weird to me. It's 2025. Why don't we have a GUI for everything? Like, why are we going back to the terminal? But I do have to say that I found the CLI to be pretty straightforward, and there are a few integrations with VS Code for showing diffs in the window, so it's not just like all in terminal. I think that would be hard. It does show your diffs up in VS Code, and so it's very, it feels normal and natural, like it looks the same way as that you would do, or you see a change set in VS Code. And so it's not like totally terminal based. And I have to admit that I can see how the CLI is easier to integrate into like more environments because it is just a terminal, and basically any coding environment can use a terminal. So if you wanted to use this in like JetBrains or Visual Studio or in Cursor or Vim or whatever, it just kind of works out of the box with everything. It just misses some of the maybe like niceties of them. And so I think from that side of things, it totally makes sense that this was a terminal based application. And so it does have some shortcomings, but it really didn't affect me as much as I thought it would, and I actually kind of like it. Now, I did find myself using Claude in browser for most general Q&A. It felt natural to me as it didn't pollute my Claude Code session with random tangents. I think Claude Code uses up its usage and limits faster because it's reading a lot of code, and so I don't want to confuse it by asking something random about like a feature in C# or something like that. And so for those kinds of questions where it's more generic, it doesn't have anything to do with my project specifically, I like to go to just the web browser because I can just open up a new chat and ask it and I won't get confused. But I will say that for targeted Q&A, tell me why you're doing this, or anything that has to do with the project itself, Claude Code is still very reasonable. It's still Claude under the hood, so it does do Q&A fine for those things. Quick note on this, because I saw a lot of different answers online, and a lot of Redditors thought this was a hack, but it's actually not, is that it's a common myth that Claude Code, the web, and desktop all have separate budgets, but the official answer is that they share the same limits and usage in the back end, which totally makes sense. Why would they bill you separately across this? And so if you run out of, Claude Code, then it's also going to be run out on web and desktop. And there's really no way to get around that. Although some people do say that if you're fully run out, you usually get a few extra asks and the other things. So something to try, but the official answer is that it shares the same limits. Okay, the second thing I took away from this is that Claude Code is the best agents that I've used so far. Claude Code is by far the best coding agent that I've used. Quick caveat that I've only used Cline and Copilot for agentic coding tasks. I've looked at Cursor, but don't have extensive experience with it. And I know that there's plenty of other solutions out there, whether it's Rue Code or Aider, the new Gemini CLI and stuff. And so I just don't have experience with all of them, so this is just, my experience based on the few that I've used. And I think Claude Code is just the best at taking my typed instructions, creating a reasonable plan for it, and actually one-shotting that plan. I find that other ones can do this, but they often need a lot more direction and iterations and hand-holding to get it done. And so Claude, I think, is just a step above those ones that I've used. even using, Claude Sonnet, Incline, and Copilot, it just seems like Claude Code is better at this for whatever reason. Now, one thing that stood out to me is that Claude Code is really good at finding the files and code that I'm talking about just from descriptions. I find that other ones can do this, but by default, they prematurely limit their search. Often to just like open files or files that have like an exact match for something you said in there. I'm assuming they do this to limit, token spend, and it makes sense. Like you can see how much everything costs in Klein, and Klein quickly like costs dollars just to like read something. And the difference here is that Claude Code doesn't seem to have this restriction, and I personally care less about token spend because it is that subscription. I know that the subscription is going to refresh in a few hours anyway. And I, rarely hit the limits myself. And so I just seem to care less about token spend due to this model. And I think because I care less about this, it's going to read more. And so it better finds those things that I'm talking about. But that's just my experience. This might be wrong, but it seems way better, at least at finding what I'm talking about from descriptions. That said, I do think that, linking files when you know them is probably best practice, as it saves a lot of time because it doesn't have to like go parse everything to figure it out. It's probably more accurate because it might get it wrong. And it saves a lot on tokens, which I think is super important over a long period of time. So it's not wasting time just like rereading everything. You've just told it what to look at, so it can save all of that. And then for larger code bases, it might not even be possible for it to read everything. And so, I'm just building a little C# library, pretty small. It can probably read the whole thing and like whatever. But for like a big enterprise code base with like hundreds of thousands of lines of code, this might not even be possible, at least within the limits that you get. So definitely link your files and directories, if you have them available. Okay, my third takeaway is that Claude Code feels pretty fast. It feels like a power tool. It can code far faster than I can myself. And I think when it gets it right, this is a huge improvement for me. For example, I asked it to add XML documentation on all public members to remove an annoying build warning, and to add tests for my benchmarks to ensure that we were building similar HTML with each framework. These are both things that I could have done myself. They're not like hard, but it is relatively low impact for a lot of typing. And so by asking Claude Code to do this, I saved myself about 30 minutes each and freed up myself to think more about the next task that I wanted to accomplish, rather than spinning my wheels like copy pasting XML and, like changing the summary slightly. Like that's just really not a good use of my time, and this thing really excels at that. Now that said, I do want to caveat that while Claude Code can code faster than I can in terms of just raw typing speed, there's a balance here, and as every software engineer knows, raw typing speed was like never the bottleneck. But I am coming around to like it is a bottleneck, and so by making that faster, you actually do win some things. But here's my take on balance. So I think Claude Code is faster when it gets it right. But if I have to redirect it around 3 times, then it often becomes slower because, I have to read what it's doing, and then I'm like, oh, this is what you did wrong. Here, redo this. Or I figure out like, oh, I probably gave it a bad prompt. Let's like restart. And it is so much faster at the coding that I think I can do this like once, maybe even twice, and it still ends up with like a finished solution faster than I can. But if I do it 3 times, it's almost always slower, and this doesn't even account for like the need for me to actually go and code review what it did, because even though it can finish faster, it doesn't necessarily mean it did exactly what I would have wanted it to do, and so there's kind of that buffer space. But I think if you just have to redirect it once, like it's almost definitely faster than me coding myself. And we'll talk about this later, but checkpointing and small atomic tasks I think help here to make sure that we minimize rework, and the rework that we do have to do is really small and time boxed, so that we don't spend more time redirecting it than actually making forward progress. Also want to caveat that while Claude Code is faster than typing than me, it may not be faster than other AI agents. I think what makes Claude Code feel fast is really its ability to one-shot successfully, because it gets faster throughput from like description to like actual finished product that I'm willing to accept. And so I think its throughput is faster from like input to output, or input to outcome, I should say. But my guess is that other AIs are actually faster at output, actually like, returning tokens faster. And the last thing is that I think Claude Code's ability to do things in the background helps it feel faster, the ability for it to auto-edit, to auto-accept things. And I think again, that it might not be the fastest in raw output, but the ability for it to go munch on a problem for a while I'm doing something else, maybe I'm doing some project management, maybe I'm taking notes, maybe I'm thinking about the next task, that makes it feel faster because it's less hands-on for me. And so more of my cycles are spent on doing other things while I don't have to handhold it. And for me, I think this is really the big unlock of agentic coding. Like, yeah, there's people who say like, oh, we're gonna have 1,000 agents in the cloud like working, and maybe we will get there. But I think for me, it's more about the agent taking over the work and being able to, with a minimal supervision, do something you've tasked it to, so that you minimize this rework and you can focus on more high-level strategic things. That, I think, is the true unlock, at least right now. My next takeaway is that you still need to review Claude Code's code. So I think Claude Code is a fast, decent coder, but that doesn't mean it always gets what you want. In fact, I'd argue that there's always something I want changed in every change it makes. This is normal. Basically, any PR by a human software engineer will have at least one thing it could improve. Some of this will be objective, like, this thing is broken, and a lot will be subjective, like don't mutate this variable, or don't use for loops, instead prefer like select or map or something like that. But there's always going to be like some feedback that you can give on a PR to make it a little bit better. But I have to say that I think the act of reviewing is very important for a few reasons and should really never be skipped. And I think these are all similar to why we do code reviews in typical software engineering teams with humans. The first is that we need to make sure that it's doing what you actually wanted. Claude Code does an admirable job of following instructions, but it still gets confused. For example, I asked it to add Razor to my project, and it thought Razor Lite was the same thing. They are similar and related to each other, but they are not the same thing. And so this is an honest mistake, something that I would totally expect a junior engineer to make if they aren't familiar with the ecosystem, but it's still one that I had to course correct it on. And I think in a code review, this is basically the same as checking the PR against the assigned ticket to make sure that the code change is accomplishing what the business asked for, having that context of like, what is the project we're trying to do? What is this task? How does it fit into that ticket? And making sure that that's actually aligned within the code change. That's something that is super important. And I think AI can do this, but for the same reason we don't have people review their own code because there's like biases there, it's still useful to review, your AI's code as well. The next useful thing is making sure that the code is reasonable. In a code review, this is the same as giving suggestions for improvements or pointing out bugs when you see them. I found that Claude Code sometimes will add superfluous checks or write an operation 5 times instead of using a loop, or pull in mock for testing. These can all be fine and workable in some situations, but they just might not be consistent with your code base, and so we want to clean up the code while we're here, and so another good reason to review your code. And finally, making sure that you understand the code. One of the biggest benefits of code review is making sure someone else understands what's going on. This helps prevent knowledge silos and single points of failure. If that engineer is gone, is there anyone else who could step in to fix or build in this area? And that engineer will be gone, whether it's for vacation or they left for another company or another team. And so it's really important to break down these knowledge silos so that the team itself, the reason that this code exists, doesn't fall apart. And I think another point to call out here is like, engineer will usually stay around for a while, even if long-term they'll probably be gone. The AI will be gone as soon as this chat context is lost, because it's stateless. It doesn't really remember things, and even if it remembers things, if it's stuck with the current context, even if you spin up another one and it has the same context, it's still going to be stuck. And so I think breaking down these knowledge silos is even more important with these AIs. And I think this is useful in production software, but also on side projects, so that when the AI gets stuck or makes a mistake, and it will get stuck and make a mistake, you know enough about the project to get it unstuck. Because if you don't, now you're both stuck and you've got fire on your hands, and there's no one who knows how to fix it. And so it's kind of one of those things that's like, you might have gone faster short term, but long term, because this is going to happen, the pain of being absolutely stuck on this is going to be higher than if you just understood a little bit as you went on. Now, a cycle that I found useful is to get Claude to code an atomic task fully. You can just accept all edits, you give it the description, and you just let it run. And then do the review in my editor by looking at the git change set. And this is kind of how I'm doing reviews, but also coding. And I think this has a few benefits. The first is it's easy to roll back. Git commit provides natural checkpointing. I see a lot of vibe coders and people who are clearly not software engineers come in and they're worried about checkpointing. They're like, it was working, and then I asked it one thing and it broke everything, and I don't know how to fix it. Now I've lost 5 hours of work, or 2 weeks of work, or whatever it is. And that's so weird and easily solvable, and you should solve it by using version control. And if you always make sure that the last thing that you committed is workable, which is trunk-based development, then the next time you ask it to change something and it gets it wrong, you can easily roll back to the next and you know you have a working solution. The next thing I do is, or the next reason that this is useful is because you can see all the relevant changes at once. Claude Code likes to change, one thing at a time, and then it will try to ask you to accept it. But if you accept all edits, then you can see the full range of files it's doing, so you can get a better picture of like what is actually being changed. And this is more like what we're used to in a regular code review process, right? The engineer works async, then they put up the PR and you can see all the changes, so you can get a full understanding of what the logical change was and if it makes sense or not. And so I think this makes way more sense than just trying to look at the one file that Claude changed and being like, does this make sense or not? Because it's hard to figure it out in isolation. Another benefit of this is like you're not using the terminal to check the changes. Obviously VS Code has an integration for this, but every IDE or process is going to have a way for you to look at change sets for Git. And so by just having it do all the change sets and just reviewing it as if you were reviewing regular code, ideally if you can do it locally, you should do it locally. Then you can use whatever editor or display you like for code review, which I think this makes this feel a lot more natural and effective. And the last thing is that this uses time more efficiently. Claude is agentic, and so to get the benefits of an agentic AI, you want to let it go and do its work async, figure out its problems, finish up, before you come in and see what it's done and check if it makes sense and stuff like that. If you're always kind of just like hovering over it while it slowly like outputs code, like you're not really gaining anything, right? Like you could have just been coding that yourself. And so I think this more kind of code review async cycle makes a lot of sense for agentic AIs like Claude Code. Now, if I was using this on a team, I would do the local code review first before pushing up to remote code review, or probably local code review first, and then I'd push up to a draft on remote so it can run whatever the full CI process is before then pushing that to public for actual teammates to look at. And this I think protects everyone's time. Make sure that you're solving all the problems you can by yourself before you waste anyone else's time to even look at this. And I also think the key point here is that local code review should not replace code review from others. Just as like the AI shouldn't review itself because it's kind of in a silo, you and the AI should not review yourselves because you also have your own biases, and you should always have another person, I think, review this code if you're going to actually ship this into production. One thing I'll note is that I didn't have an agents.md or claude.md file, but my bet is that this would cut down on the amount of subjective code review changes I asked of it, as it can encode best practices for it to follow. And if you're not familiar, these files are kind of like instruction sets. They kind of will often outline what the project is, kind of the main points of the project and stuff, kind of the best practices that the agent is supposed to follow. It's kind of like an onboarding doc to a new repo. And this is important because every time you start up a new chat with an AI, it's like a fresh new engineer that needs to be onboarded. And so the more that you can give it all the info it needs in one place, theoretically, the better the outputs are going to be, because it's going to have ramped up more on the code base. And so I didn't do this, but that's something I need to do an experiment with going forward, because I bet it would make the code outputs a lot better. The next thing I learned is that Claude gets overwhelmed, and so you should really break down the project into smaller steps. So while Claude is good at planning and execution, it breaks down when tasks get longer. And I think people say it's good at planning and execution. I think it's good at planning and execution in isolation. Just giving it a full project that it needs to like chunk down all itself and munch on, I don't think it's there yet. And in many ways, it feels like a junior engineer. Like it can code, but it doesn't have great project management skills. So similar to a junior, it works best if the tasks it's given are pre-scoped and described. Give it too big of a task and it's going to spin its wheels trying to make progress, often getting blocked on broken builds while boiling the ocean. And I think we might have mentioned this a bit earlier, but when I give it like a big project, like a full feature or set of features that I want it to build, and I just let it go and run with that, what it'll tend to do is make a huge to-do list of things to do, but the ordering is maybe a little off. Like maybe it will try to build all of the views of the different features at the same time, or it will do like kind of cross-cutting concerns at the same time. I'm not really sure how to word this, but it'll do things that kind of are parts of different features all at once. And the problem with that is that there's no clear milestone of like to checkpoint this and check if it's okay and then commit it. And so it will often do that, get like halfway through, and then something it did for feature, let's say C, breaks, and then it can't figure out how to fix that. And so it kind of goes sideways, and now you have three broken features, right? Like A, B, and C. And I've seen this very frequently. And so I've decided to like take a step back from this and find a different way to solve for this, because it really just doesn't seem to be able to do these larger tasks all at once. And so a better approach that I found is to make a plan and break it into chunks. So it's like you're planning, let's say an epic, and it is really just the same way that you break down real world software problems into projects or epics and then into subtasks or milestones that you want to do. And then I take each of those individual tasks and I feed that context and the task into Claude and have it go work on it. And I think this is the same way as like I'm a human engineer. First I break down the project and then I go work on something. I'm going to pick up like one task at a time to work on, but I will have the context of the broader project kind of directing me or giving me general direction, but I'm really only working on one project at a time or one task at a time. And what I find is that this allows it to one-shot its tasks better. And I think this is where most of its productivity comes from. So again, if you can get it to one shot and remove the rework, that's really where the productivity gains are. And I think it gives natural points for checkpointing and reviewing via atomic commits, which kind of makes that whole cycle a lot faster. And so I think it helps me as well stay on track with what we're trying to accomplish, because again, Claude will make like this huge to-do list of like 15 things to do and it's doing them, but it's unclear where like a good checkpoint is. And so it gets stuck because it like broke some random thing somewhere. And now I'm like, well, what did we even do? What parts of, feature A, B, and C are finished? And so it gets confusing if you just let Claude to do this. And so if you break it down yourself and you have your notes somewhere and you feed it one at a time, then it reminds you of like, oh yeah, we're trying to build this feature. And here's the next features that we're going to work on. And, while it's building that, you can think more about the rest of the stuff. And so I think overall, this is just like a much better cycle. Now, as an aside, I think the atomic commits and PR stacking workflows work really well for AI. And this is kind of what I'm talking about with atomic commits. And they also work well for humans, which I think is one of the reasons why it does work well for AI as well. It's really about managing context. And they allow you to make progress on discrete items and have logical checkpoints to review and roll back to in case it goes off the rails. And as any project knows, there's some tasks that will just go off the rails and you have to restart it. So, planning for that makes a lot of sense. And I think it's a little bit more time per change. So short term, more expensive, but overall it improves the throughput by reducing the amount of rework, which in any significantly large project or team-based thing, this is almost always the trade-off that you should make. Now, I will say that I've seen some people say getting Claude to track its own work and progress in a markdown file has been useful for keeping it on track and for, breaking it up into milestones that make sense and stuff. Now, I haven't tried this yet, but I bet it does keep it on track for bigger asks, but I don't know if this solves the problem of it not having good milestones, where it tries to, again, do parts of like A, B, and C and the front. So if like it gets broken down, you've made no progress at all and you have to do all rework. But in my next experiment, I will try to do this in a way where it keeps context, but also only does one logical change at a time for checkpointing, because I do think this is probably a pretty good way to at least power up its understanding of where it is so that it can remember that. And my final takeaway is that Claude still needs a driver. Claude is a good coder. It feels like magic to give it instructions and see it churn out code, but code, like words, don't really matter. It's not the output, but the outcome that matters. Claude is great at output, but the outcomes are still highly variable. It still gets bogged down in large tasks. It still gets confused and does the wrong thing, and it still codes in some non-optimal fashions. And in this regard, it reminds me of a junior engineer. It is super useful, but it requires significant direction to make forward progress and to really get any kind of productivity out of it. And I think the metaphor for power tools also fits here. A large productivity improvement in removing manual work, but it still requires strategy and preparation to use effectively. Like going from a manual saw to a table saw, it cuts things much faster than you would yourself, but you still need to know how to use it, provide the projects that you want to work on, and know how to do all the other things required to finish your project. Next. So I had a good time building this C# library with Claude and was so impressed that I've upgraded myself from Pro to Max. I rarely ran into limits with Sonnet 4, but I wanted to try out Opus, and Max lets me do that. And I'm experimenting with more ways to use it as well, so I'll probably be hitting these limits more in the future. Now, I'll be doing more coding with Claude in the future, in addition to how I currently use it, which is mostly as a better Google for technical references. Overall, I'm way more positive about AI coding agents than I was previously. It was a very useful pair programmer and will help me build more things in my limited free time while raising my kid. Now, if you use C# and are looking to build composable HTML server-side, check out Cinderblock HTML. It's vibe coded, but I do promise I reviewed almost all the code. Now, if you like this post, you might also like introducing Cinderblock HTML, more on what it is, how to use it, and why I built it. Might also be interested in my 2025 job search as a senior software engineer, my results, my timelines, and how I study for interviews, including a lot of data and data visualizations. And finally, my career in programming languages, basically a walk through my full career, where I've worked in the programming languages that I used, and kind of my reviews of each. So that's it for this video. Thanks for watching, and I'll see you in the next one.